Good morning, everyone. Thanks for inviting for this talk on Kafka. Okay, we will talk about the Kafka and idea about in this program. Before we start, let me just give you a brief introduction of myself. Okay, I am Henry Potsenbaum. I'm a consultant and trainer, specially focused on the big data. I am the author of this book called Learning Couchbase. This is an in-memory database used in wide varieties of domain, especially in the e-commerce domain. I'm certified from various vendors regarding the big data and the enterprise architect from TOGAF too. Okay, how do I plan this 2 hours program? I'll just give you an idea about Kafka. Where do we use this Kafka? And then we talks about how much these other messaging systems available in the market differentiated of the Kafka with respect to other messaging broker. And then I will just demonstrate about the various processes, the various configuration that you need to do when you deploy the Kafka in your environment. And then we'll talk about the architecture of the Kafka topic, where we understand the partitions, where we understand about how the publisher published the message to the topic. And then we will run a short demonstration where I demonstrate about the Kafka consumer group. Okay. And after that, we will try to address some of the components that you will require to deploy in your enterprise applications. Like when you deploy the Kafka, there will be a requirement for various components. So if you have an idea about the various components that build up around the Kafka, then when you deploy your Kafka application, you'll be able to integrate as when as the requirement comes in. Sometimes you may not have an idea about that this particular component exists at all. So like, for example, most of the time, if your application get deployed in and around the environment or in and around the environment of the Kafka, the best way to transform the data from the Kafka is using the KStream or the ksqlDB. But I have seen a lot of enterprises, they plug in the Spark, they plug in the Flink on top of the Kafka. Yes, if you have another requirement, which is other than the Kafka, then it may switch the requirement. But if your deployment it's in the center of the Kafka, the best way is used to use the ksqlDB and the case or a KStream. I'll not talk much about the KStream or ksqlDB, but I will let you know that these are the features that are available in your Kafka ecosystems. Okay, any doubt that you have it in the interest of the time, please put in the chat. I'll just try to look around on the chat, and we'll try to address your query then and there itself. Okay, and I hope we'll make it more interactive. And if you have any query, I would love to address as much as possible if it is within my domain. Now, before we start understanding what really the Kafka is, let's try to understand where we use this Kafka. Actually, Kafka is used predominantly in two categories. So when I said two categories, means the group of application that you will love to use this Kafka, or the Kafka will give you the advantages in deploying your application. So the first things which Kafka is recommended is in the microservice environment. So when we said microservices, that is when you have a different service get deployed to solve an applications or a business requirement. And if there's a need for the applications to interact with each other, then the Kafka is the right candidate for that. So let's say, for example, in this example, we have the order applications. Okay, so we have the order application here. Now, let's say you have designed an application where you are accepting an order for an e-commerce domain, and you are selling various products on your application website. a customer comes in and places an order for a particular product on your applications. And then what happens is that there is one more application running, which will be sending the information about the order which the consumer has placed it. Like, for example, the product ID, the item cost, and when will it get delivery, that particular product. That all information that you are going to send an email to the customer email ID. Now, when we deploy using this, using the Kafka, what advantage that you have is that you have loosely coupled between your order services along with the email services. If I have to do in a very traditional way, what will I do is that from the order service, I'll invoke the SMS gateway directly, or I will invoke the email service directly. But what problem that you have is if the order service tightly couple or invoke the email service on the same thread or the same transaction, what happens is that if the email gateway is taking time to process that email or sending the email, then it's going to impact to that. That's another one. Another case is that if I want to change the logic of the email, then again, if I change the structure of the input or anything that I change it, then if I have to bring down the email service, then your order service is also going to impact it. So what we achieve is that we put a one broker, we put an intermediate layer, where we don't know that who's going to be receiving my information at the other end. So it helps you to solve the loosely coupled advantages. And now another scenario comes in is that your business analyst says that it's not suffice enough to send the email. Why not we send this information using an SMS applications? So I'm saying is that we will send the order information to the customer using the SMS. Then how do I do that? I just plug in one application here. Then I don't need to inform the order service application that we are developing this SMS applications, and then you need to invoke this particular URL or the services from your application. So we loosely couple all the dependencies. So the second advantage that we have is we can plug in another business requirement without tightly coupling with the source of your data. Now, that's the second. One more important thing that we have which is very important in terms of the performance, that is, if I am generating 1 million of orders, and say, for example, during the festival season, the order has been increased from, say thousands to about millions of record at the same time. Now, this guy on the other side is pumping data at a rate of 1 million per second because of the festival season. Now, if my email, the one which is going to send the email application, is not able to pop up, then you have a problem. But if you use this kind of the deployment using the Kafka, then you solve the problem, because he doesn't need to worry about how the downstream application is performing well or down. For him, he just keep on he just need to keep on inserting the record, and at the another thread on the background, this guy is going to pick up the record and send it. Now, this is the advantages that you deploy using the Kafka. Yes, you may have the query that why only Kafka. You can also use some other messaging system, like you can use from the RabbitMQ series. You can even use from the right, this one. Now, you can even use the commercial product from IBM, or you can even use from Microsoft or Oracle. But you can even use the open sources like Apache Kafka, and you can also use the RabbitMQ, which is very famous messaging systems. But I'll tell you what are the difference and what you're going to benefit when you use this Kafka broker in deploying such applications. So we can keep on information about the orders. You can also maintain about the warehouse inventory. Like depending on your business requirement, you can create a repository for the time being. People who are new to the broker side, just imagine that the broker or the messaging system or anyone talks about such category of messaging system, you just assume that this is a repository or just like a databases, but it has some functionality that helps you to pick up the data or push the data to it and fire and forget about it. So we'll talk about more in detail as we move on. The another use case is where we deploy Kafka is in the big data landscape. So when we say the big data landscape is you have your transactional system out here and you have your data warehouse or your data lake or your something. So you can have it using a Hadoop environment kind of stuff. So what does it mean is you have a lot of application running. So in this where you have a mobile app, web application, IoT, there are a lot of information coming on the transactional, on the real time. And then what you want is you deploy the same cases, you can deploy any broker or any messaging systems. However, in our example, we are going to deploy the Kafka broker here. So when I said the broker is nothing an instance of messaging systems. So it's just like a database instance. Okay, so it's a database instance. Now, we publish the informations, and since the data are generating on the real time, we call it events. So we push the record or the events or your data, for example, in our case of in our earlier example, we have an order. When an order comes in, the order information will be sent to the Kafka, and then Kafka will use to pick up. Actually, it's not a push, it's a pull. Okay, so it's a pull. So it's not a push by the Kafka, never push the record. Say I have my data warehouse. In this example, we deploy in the Amazon S3. This client can pull the application, the records or the data from the Kafka and then store it. So on the real time, we can push the record on the real time. Like if you do a traditional ways of doing it is you have your, say, for example, if you have your transaction system in Oracle DB and you have your warehouse in deployment, the Hadoop or data lakes, or you can also deploy using from Confluent also you have, or you can also have it from the Spark deployment. If I want to bring the data from here, what I can do is I'll just pull the record with some applications. I'll write some code. Then I need to keep track about the incremental changes that I want to transfer to this particular data warehouse. But if you deploy this, you don't need to worry about incremental changes. You keep on changing it. Depending upon the kind of the platform that you have it may override it, or you can also have the incremental changes with the timeline. When I say timeline means a particular order at 10 o'clock, what was the value at the time? And if this particular order is updated subsequently, say around 10:30, I can run around the timeline to see the state of that particular order in a particular time. But depending upon the solution that you have it on the data warehouse side or in your data lake side, you can find out the incremental changes that you have it. That means you can understand the state of the data at a particular point of time, and then you can get a value about it. So we use the Kafka predominantly in two categories. One is the microservice environment, and another one is in the big data environment. So what does it mean is why, say, when we said about it, Kafka is very, very famous nowadays. Like any guys, any forum that you go for it, we always talks about a Kafka. And even for the job, the people talks about the having the skill of the Kafka is a very plus point. So now, what really the Kafka? If I have to define this particular system is I'll come back from here, is a public pub/sub messaging system. So when I say the messaging system is nothing, a repository that allow you to publish a message and consume a message. So the message is nothing new data, but in terms of the messaging system, the data or even that you store in the messaging system is called a message. So when we said about that is the Kafka is a pub and sub messaging systems, as you have in your the Apache Cupid or RabbitMQ, they all belongs to the messaging systems. Now, the main differentiator is very fast. I'll talk about why the Kafka is fast as compared to any other messaging systems. And scalable is very important. These are little bit interrelated, and why it is interrelated we'll just discuss subsequently. And the durable, that means you can store your data, and you can even predefine that the time to leave of your data, that you can specify in terms of size. You can even specify in terms of time. That means when I insert a record, the record can be or has to exist in that particular storage for an 8 hours or 365 days, or it can be also defined that maintain the data until unless the log file is about 25 GB or 1 petabyte of data. Depending upon your requirement, the Kafka ensure the data are durable. Here, I just want to highlight the difference between the other pub/sub messaging system is when the data that you inserted in the repository or in the broker, and if it get consumed by the subsequent services, that message get removed from the storage for most of the pub/sub environment. Wherever in the case of the Kafka, the message will be still there, provided you define the time to leave for the particular message or the size of the log file. And the fault tolerance is also related with the scalable. When one of the system crash, it ensure that your data get available in that. So we'll talk about this internal as we move on. So I just want that when you move out from this particular meetup, you have an idea that what's really going behind the Kafka. Okay. Now, it's used in the real stream data. That means data coming continuously, and that it's used for analytics. Now, when we said analytics, if I want to say how much order a particular person has placed in a range of 5 minutes, or say if a person is buying about say around $5,000 in an hour, then if your application feel the business logic says that you'll give some discount to the subsequent order, that you can process this kind of things using the KStream on the real-time data. Now, it's used in a wide varieties of the use cases like service call, any events. If you think nowadays, anything that generated data on the real time can be treated as the candidate for using the Kafka deployment. I have seen a lot of organizations that move from the enterprise message systems to the Kafka in the last 3 to 4 years. I have seen the people moving even from the IBM MQ series to the Kafka because of the scalability as well as the maintainability. Now, Kafka is often used instead of JMS, RabbitMQ, and the AMQP protocol. AMQP protocol is something that is we don't define by API. We works at the system level, so instead of specifications, so that it can have the vendor neutrality, or you don't need to like in the case of JMS, then you have to write your application only in your Java, and then if you have to correlate or if you have to connect with the .NET, then you need to find a intermediate converter. Whereas in AMQP, it doesn't matter all because it works at a protocol level, and it has a very high throughput. And high throughput is because of the some of the concept called the partition that we'll talk about it, and reliability, and the very important is the replication that you have it. That means you can have a copy of your data, okay, so that in case one of the host or the broker fell, then you can replicate the same data in other nodes, and then it can becomes the source of your data, and then you can pick it up your data on the real time without any downtime. Now, let's say Kafka is very popular by now, but then why? So we always say as artists, it's sometimes very fancy. Also, people talks about it. We use Kafka, then I know Kafka, and we talks about Kafka in length. But why? So why the Kafka is so popular in that? And then the main reasons why the Kafka is very popular is because of its performance. And we'll see later on as we move on, then when you said performance, what does it mean? And we all talks about that the Kafka is a performant messaging system as compared to the others in the market. But what does it mean? And then how do it provide this performance to the application? We'll talk about it. Simplicity is something that we are debatable, because the Kafka is now become the huge ecosystem by itself. When we started deploying Kafka around, if you happen to follow this Kafka around 8 years or 9 years ago, you have only the broker, and then you pub and sub, and then that time you don't have a KStream, you don't have ksqlDB where you extract the data. You have to write a Java API where you create the record and then you push it, and then you have to write a consumer where you pull with predefined time, and then you process the data. That was a little bit tedious if you happen to work in Kafka about 7 years or 8 years before. But now we have various varieties of component that we'll talk about as we move on. And the very important features that Kafka differentiates from other is that the consumer group. We'll talk about this in detail. When you have a consumer, that means, say, for example, this is your Kafka topic. The topic is nothing your storage where you store your data. Say, for example, I created a topic called order, and these are the SMS application that we are going to push it. So now what happened here is, if I have 50 messages out here, so what we'll do is that I will divide 50 by 3. I cannot just divide by this 3, okay? I'll tell you how logically it moves, but for timing, just to have an idea. So if I divide 50 by 3, say, for example, I say 15 or 16, 16, and the remaining stuff that will, some these are processed by this. The remaining one, that is 32 minus is 40, and that is around 18. Okay, it may be 17. Now, if I feel that in order to dispatch these 50 messages to send SMS, I took around 10 minutes to SMS this. So what I can do is that if the business says that is, I cannot afford to wait 10 minutes for sending this SMS, I said, bring it down by half. So what I can do is that is, I can spawn this. You don't need to rewrite your code. You just need to bind all this application in one group called consumer group. I'll show you how to do later. So then I can increase the number of threads, and now it can divide 50 by 6. So I can bring down by the half by dividing this. Yes, there is some relationship that you need to do. That is called the number of partition that you have to create it. I'll show you how to do that. So there's some design you have to do it. You cannot just do like that. You have to design in mind that how much record that you are going to have in your applications and what are the SLAs. So there are some scientific method that helps you to calculate this breakup for your applications. And now replications are of two types. One is from the same cluster, and another is for the disaster recovery or for your warehouse. We talk about this later. So there are two types of replication that you have it. Now, this guy is what I talks about it. Whatever data that you pumps in your topic, you can transform to that. Like, for example, I received the order information in a JSON format, say order ID is called 12, and say the item number is 16. Now, if I have to send an SMS to an application to the customer, I cannot say that you place an order 12 and your item ID is 16. I need a description for that. So this are transformation you can do on the real time using this the KStream or the KStream or using the ksqlDB. I'll just give you some idea as we move on. So now if you seize this Kafka as an overall systems, it helps you to the ETL process. You extract the data, you transform that, and then you can load the data back to, you can load in the broker itself, in the Kafka itself, or you can also dispatch to various systems. Then you need to use the terms called connector that we will see if I can highlight some of them out here. Now, we talks about why the Kafka is so popular. Now, the very main important thing that I want to address it out here is why the Kafka is so fast. So one of the very important things that Kafka is so fast as compared to other messaging system is one concept called zero copy. The zero copy allows you to bypass some of the system code, especially the clock cycle. I'll show you in that. And it allows you to access your data directly from your memory. So this gives you the differentiator from the other messaging system, which they don't use the zero copy. I'll try to highlight what it really works behind. Another one is the pairs cache. In most of the messaging systems, what they do is they cache the data in the heap memory. However, the Kafka doesn't use the heap memory. He used the OS cache. So what is the difference, or what give the advantage is about the garbage collections. The garbage collection is the main problem when you cache your data in, when you put your data in the heap memory, because when you do the garbage collections, they are divided into two collection. Then it's called minor garbage collection. Another one is called the major garbage collection. If you have too frequent the garbage collection, you have a problem because your memory is not able to cope up your data. And then if your garbage collection migrate or move from the minor garbage collections to the major garbage collection, then you have a problem, because at that time your thread is going to be whole. That means any request that is coming to that particular point, it's going to be hung for that until unless you complete that cycle. Your process, your application will be up, but the thread that is going to serve the request is going to be waiting for the garbage collections to be completed. So a lot of time what will happen is that when you deploy any Java-based application, you'll feel that my app is done, everything is fine, but application is not responding it, because when the major garbage collection happened at the time, your application whole till the major garbage collection completed. All that information you can see in the log if you configure the log properly. Another one is the batch your data in chunk. That means when I send a record, the Kafka has the options to push the record in the chunk. When I say chunk, it allows you to send the record in terms of size. Say, for example, bundles in around 100 MB and push it, or I can say the wait around 10 milliseconds before I send the records to the other one. But you need to keep in mind that when you enable the batching, the latency is something that you can afford, because there will be some delay to that. So depending upon your load, you need to choose which one to use it for it. The main problem with the Kafka is that a lot of functionality and features are provided, but you have to configure it. And if you don't configure it properly, then it's going to give a lot of problem. Because if you configure, say, for example, your latency is 10 milliseconds. Now, if you do not have enough data in 10 milliseconds, that means you are delaying, or your latency is very high. Because anyway, you are waiting for your data for 10 milliseconds to push to the broker. That 10 millisecond delay is there, and you don't have much data to push in. So you have added too much latency. So you need to keep in mind. Another problem that you incising is that if you define 1 MB, but if you take around, say, 20 milliseconds to fill up that 20 MB of data, that means you have a latency of of 20 milliseconds because you have to wait for it to fill it up. But if your application is generating too much data, say for example, I am generating about 10 MB in a fraction of a millisecond or in 1 millisecond, then it's good to decide, because every 1 millisecond is going to push the record when I define by the size. So you need to know the pattern of your data to understand that which one is suitable for you when you configure this chunk. Now, another the advantage the Kafka provide in the performance is that is when the Kafka has a log, I'll show you the log later on. When you insert the record, it will keep on appending to that. So there is this is called the last log offset. Okay, so I will have a pointer to this offset. When a new record comes in, it will plug in here. So I don't need to go for seek and scan. In most of the messaging systems or in database, what they do is that they look for the record and they insert it or they just scan for it. So that seek and scan, that particular time latency is not required in the Kafka because the Kafka keep on appending it. So this is the main advantage that the Kafka provide as compared to the other one. And another one is technically is the horizontal scale it out. That means I have one machine, I can keep on adding it, okay? And then it can form a cluster of it. So that is the one advantage that Kafka has it. So this is called the horizontal scale out. Now, before I give you, I give some demonstration on how the Kafka operated in behind technically. Let's try to understand what concept is called a zero copy all about. Now, if you see, if you deploy the concept of zero copy, which the Kafka does it. So how it does it in behind is like this. This is your log, which is stored in your any log or data. This concept is applicable for any system that store the data in a file, okay, like databases or any broker, LDAP, anything that's stored in that. So if I store my data in log in a file, so when your Kafka says is I want to read the record, what it does is that is actually it will signal to the kernel context, which is not in the application context. This is your direct system call. Then what happened is that it will fetch the record depending upon the file or your data that you have it, and now it will store your data in the buffer that's called the read buffer. But this read buffer is the buffer in your system kernel, and then it will dispatch your message or your information directly to the socket. That is nothing for your network buffer, and then it will send to your NIC card, and then it will transfer your data to your TCP IP layer. Now, so if I have to understand in terms of system call is that is this U means user context, that means your application context. So for in this example, this is your Kafka application. Now, when I want to fetch the record, what we'll do is that is the application will invoke that the call to the system saying that is I want to read the record, and now the kernel context will not pass on that data back to your application context. That means it's not going to use the cache of your this one. It will just send it here, and once that record has been sent to the client, it's just confirmed back to that. So that means it has only 2 clock cycles. That one is for invoke, and another one is called that I am confirming back that is done. Now, if you see that is, in order to switch this time, it say, for example, it takes around 1 millisecond, depending upon the clock cycle of your processor, depending upon your load, depending on the CPU type that you deploy it. So for example, it takes around 1 millisecond. So in order to dispatch one messages, actually, it's takes 1 plus 1 millisecond. That means 2 milliseconds. Now, just imagine if I have millions of messages, okay, millions of messages, then that much delay that you're going to have it. Now, if I don't deploy the no zero copy, this is a traditional way of doing it. So what it does is that is, I said read the record. Now, He reads the record, he passes on the record to the application layer. So now there's one switch on that context. It passes on the application here, but the application cannot send the data directly to the TCP/IP layer. So what it does is that it passes on back to the kernel context, says that is this record need to be dispatched to the client. So you store your socket and then send it to the network code buffer, and then it goes to your client layer. Now, what it does behind in the system invoke is that is before the read, it invoke. After the system call, it sends the message back to the user context. The user again says, send this back, listen to that. He sends it, and then he confirms back. So if you see that 2 more additional hash comes in now, 2 more clock cycle now. So if you don't use the zero copy, you're going to have 2x time, okay, whatever time it takes to do that. And if you use the zero copy, it will divide by 2. So there will be a difference of almost 2 times. So these are the main advantages which Kafka designed in the backend to give you highly performance messaging system as compared to any of the messaging systems. Now, we talked about the why Kafka is so popular, why the Kafka is so fast, and where all we use is Kafka. Now, if I have to deploy, so now we know the plus point of the Kafka is that Kafka does this, and Kafka is the performance and all. Now, we decided that we will love to deploy the Kafka in my environment. So if I have to deploy in my environment, I need to know some of the nomenclature of the Kafka when I need to deploy. So when you are an admin, you need to understand this component when you deploy. Even if you are a developer, you need to know how it works, because when you write an application, it's all depend on this particular concept. Now, let's see what are all things that we need to deploy the Kafka. Now, when I want to deploy the Kafka, I need to deploy a component called the Zookeeper. Zookeeper is an open source framework or a library that allow you to store the data in memory. Okay, this is just a coordination services. And what are the roles it takes in the Kafka? I'll talk about that. So usually in your production environment, you'll have multiple Zookeeper. You can also deploy to one Zookeeper, but in case if that component dies, then your application will not access your cluster. So your cluster will not be accessible to that. So you need to deploy the multiple Zookeeper for in order to enhance the availability of your cluster. So in this example, we deploy 3. 3 is an ideal. You can also deploy 5 if you have a too big cluster, but 3 is the recommended one. Now, when I said messaging systems, it's just nothing your Kafka, and you can deploy 1:many. That means you can have number of nodes or numbers of brokers deployed. Now, inside the messaging systems, you will create one repository called topic. Topic is nothing your database table or a schema where you store your data. This is a logical name. Like, for example, when I discuss about order, this will be an order topic. Now, once you deploy Zookeeper and your broker, and then you create this topic, now you can have your order application. These application that send the records to the topic are called publisher. So that's why people say pub sub, okay? Pub means the publisher, or the one that sends the record. And the record is called the message in terms of the Kafka environment or in any messaging systems. Now, when you said pub sub, the sub is coming from subscriber. So in these cases, for example, we can have the email applications, or you can have SMS applications. So they consume the message in that. So we said the publisher published the message and the consumer consumed the message. This is how it works in that. There are something going behind when we have multiple nodes which want to connect, and how do the Kafka ensure that data are distributed. We'll talk about later on when we talk about the topic more in detail. Now, before I give you a demonstration about the Kafka, I just like to highlight the difference between the Kafka with any other messaging-oriented middleware. So, like for example, when you are an architect, then you want to decide why to go for a Kafka, why not other things. It's better suited for scaling out. So, if you have a large amount of data to process on the real time and you want to give low latency, the Kafka is an ideal candidate for that. And then I talked about the consumer group where you can have the multiple consumer processing the record for scalability or give the performance, or you want to reduce the processing time. So this happens using the consumer, and technically you need to define simple partition that we'll see after the demo. Okay, and these parallelisms of consumers is handled very differently as compared to Kafka and the other messaging oriented. Now, another thing is called the which I want to highlight is you have a broker. Say this is your order app that's pushing the record. Now I'm sending SMS from here. Say, for example, I have 10 SMS record to be sent. After 5 messages I consume, my application breaks down. So I have still remaining 5 records to process. When you start this application all again, it has to start sending the record from the 6th record, not from the beginning. So that breaking of the data, which we have already processed, is done by the broker itself. However, in the Kafka, it doesn't keep track about that. So the Kafka will be taken care by one process called the group coordinator. I'll talk about that. The point here is the server or the broker doesn't keep track about the consumption of the message or whether the message is consumed or not consumed. It's all taken care by the consumer. Okay, so it doesn't get overloaded. So it's only does is store the data and then let another fetch a record. So I don't need to worry about whether it has been consumed or not being consumed. That's taken care by the consumer group or the group coordinator. So let me just give you a demo before I give a demo. Any doubt that you have it or any query that you want us to highlight, let me check the chat. Okay, so far so good. Let me just give you a short demonstration. So what I'm going to do is I'm going to deploy, can you see my, okay. So what's the difference between the Kafka and RabbitMQ is they all belong to the category of message broker. However, yes, Kafka is open source and IBM isn't, but that is from the marketing point of views. But from technically, the difference is in the case of the Kafka, in the case of the Kafka, when you create a topic, what you can do is you can scale it out, the nodes. That the main difference between the Kafka and the RabbitMQ series is when you create a topic, say for example, order topic, you bind the topic to a host in the RabbitMQ, and if that host fail, then you can configure a cluster, and then you can pick up from the other nodes. But that is 1:1. That means I cannot span a topic into multiple nodes. In the case of the Kafka, what it does is I will have a topic called order. I will divide this order into 2 parts. Part 1 is, say, partition 1 and the partition 2. I will store the record of the partition 1 in one node, and I will store the record of the partition 2 in one node. That means if I have a 200 GB of data, I'll store 100 GB in one node and 100 GB of data in other nodes. So what is the advantage now here is that is if I'm breaking up the 200 data into two nodes. However, in the case of the RabbitMQ, what it does is that is it will store the 200 data in one node only. There is no way where you can divide your data into two parts. That's a main difference. Yes, in terms of speed also, Kafka is much superior because of this and the point that I talked about it. Yes, people can also argue that RabbitMQ gives you the functionality of enterprise service bus. So when you say enterprise service bus, is that it gives you the capability to transform a various connector. I say I can get the JMS and then I can convert into JSON to XML format, and then I can do it gives a lot of functionality, mapping and all. It does it, yes, no doubt. But the industry realized that most of the need that we require for the deployment of the broker is just for a normal storage and some transformation, which Kafka does very well as compared to the RabbitMQ or any other enterprise application. I hope I address your queries. Okay. Can someone confirm that? Can you see my the terminal or no? The CLI.
The PPT, not the terminal.
No. You see command line or the presentation?
Presentation.
Okay. I think I'll. Yeah, I think you can see the this terminal. Okay.
Yes.
Okay.
You can see the terminal.
Okay, great. Now, the first things that you need to do when you start the cluster is that the first thing is you need to start the Zookeeper. So before the Zookeeper, I will not go to the installation because that will take time. But just for your understanding, what I do is that is I download the so whenever you want to install the Kafka, the first thing is you need to have JDK. So I install the JDK out here, and I need to install Zookeeper. Zookeeper you can install separately, or you can. It also comes bundled with the Kafka. So I install separately, and then I extracted the Kafka here. Now the first thing that when you want to start the Kafka is the first thing is you need to start the Zookeeper first. So now I have created some script. Okay, so now regarding the public and the private advertised host, I'll just come back to this demonstration. I hope it will address it here. If you need more, I'll talk about it more, but I'll address it here in the demonstration. Now, here I have created some scripts, so I start Zookeeper. Okay, so I start a Zookeeper out here. I keep this window open, so because any lock it comes, I just want to see it out here. And then I will just see that this column here main is my Zookeeper is running. Now I will start my broker now. So I said in this example, I'm going to deploy one Zookeeper and 3 brokers at the same machine. Now, ideally, it should have multiple machines, but in the Docker, I just created in the same machine itself. Start broker, so broker 1. So I'm starting as this broker 1. Now, in other terminal, I start the broker, another broker, and on the other terminal, I start the third broker. So I started broker 0, broker 1, and broker 2. So if I seize all this, so everything is intact now, I run this JPS now. So if you see that my quorum peer main is of the Zookeeper process, and I have 2. Now what I did is I have configured the various parameters for that, because so let's see what are so let's try to see some of the configuration that you need to do when you deploy this Kafka cluster. Now I'll go back to the Kafka. There's one folder called config. Now there is one file called the server.properties. This is where you're going to modify most of the configuration when you deploy the Kafka cluster. every Kafka nodes that you bind to the Zookeeper, you have to assign some ID. It's called broker ID. So I assign a 0. You cannot assign the same numbers to the multiple in the same cluster. So it is broker ID. You can either assign this number numeric by yourself, or you can also let the Kafka auto-generate to that. But I recommend that you assign yourself in a fraction, so you know that which broker. And then now, another important properties that I want to highlight is that this I'll keep for the timing. This is what I think Indrajit was trying to ask it. I'll come back to that point. Okay. Now, then how do I know? So what is the role of the Zookeeper is it has to understand all the nodes that are part of the cluster. So there is one entry here, Zookeeper. So this is where the Kafka knows that I need to connect to this particular Zookeeper. The Zookeeper is running in the 218 port number. You can change it. So I'm running this. Now, here, if I do this 2181, this is the port number by default for the Zookeeper. So you can change it if you want, but this is what we maintain. Now, this is where I tell you connect. If you have a multiple Zookeeper, you can supply comma into that. Now, another point that I want to highlight here is there's one called the data directory. This data directory is where your actual data gets stored. So this is the folder where the Kafka log is going to maintain. There are a lot of things like buffer and all. I'll not go into this because that will take a lot of time. Okay, so these are the very important parameters that you need to configure when you deploy it. Okay, now, when this Kafka, this broker, when it starts, it goes to this Zookeeper and create some nodes called G nodes that I'll explain to you that. Okay, I'll touch upon some of the features of the Zookeeper. There are a lot of information that you need to do in the Zookeeper when you deploy in Kafka, because a lot of time people see that as the broker is not responding, especially if you use this Kafka from the Cloudera, which is bundled with the Cloudera platform. If you have used the Confluence Kafka, which is at the enterprise version, you will have a lot of performance issue out there, because it generates a lot of matrices. And then if you don't configure the various setting, then you'll have very slow in the nature when it performs. A lot of the time, people always try to verify the setting in the broker itself. But then what happens is that if your Zookeeper is not performing well, then also you'll have an impact in your classes. So you need to look from the border perspective, okay? Now, coming back to this particular listener, there are two parameters that you can specify in this. The listener. Now, when the Kafka start the broker itself, the Kafka doesn't understand which the host name I need to bind the Kafka service, or do I need to bind to the IP address. It may happen also, you may have multiple NIC card in your multiple IP configured in your machine. So Kafka doesn't know which one he has to bind. So now the listener is the instruction given to the broker or the Kafka that when you start the Kafka service, bind means you are going to listen to this particular the address. You can specify the host name, you can specify the IP, or if you want to bind anything, you will say 0.0.0. But usually you should bind with something the host name is the recommended way you bind to that. Now, you may ask, what is a plain text? If you have configured the without any SSL or something, we'll use the plain text. If you configure SSL, we'll replace with SSL. Then if you change this here, you have to change it down here, okay? I'll not go to the security that has come from the security point of view. We have a huge topic in that about configuring the certificate authority, then we bind to the trust store, and that's a different story. But for the time being, we are configuring the Kafka to listen on this particular port. Now, if I want that the Kafka is bind to this particular, but then do you want that the client also address to this? Okay, so for example, do you want the Kafka service to bind to this or not? If you don't want the client to connect to this particular one, you can change the advertised listener. So then you can change it out now. So let me give you one example, because a lot of people which I am going to the various organizations, they usually face with this problem. So I'll go with little bit explanation on that. Now, so what happened here? So in my deployment, what we do is we have one Zookeeper, this Zookeeper here, and now this is your broker 1, broker 2, and broker 3. Now let's say one example out here. Now there's one called a G node here. Here we call it brokers. Nothing your directory. We call it G node in the Kafka in the Zookeeper environment. Then we'll set ID and then 0. The 0 is what we have configured in the broker ID. Now, when this broker 1 use the listener, say for example, if I don't define the listener, say for example, I don't define the listener, what it will do is I'll go with the local host now by default and 9092. So what it does is he will register himself to this information localhost. Now, when the client, the publisher is want to send the message, what he does is he go and connects to the Zookeeper. That is said, give me the details about this ID. So he's given this information to them. So what is given is you have to connect to the 9092 localhost. But if your application is running somewhere in, say, some other IP, then he will try to connect in your same machine. That's why you say the broker host not available for this particular. Now, what we want is not like that. So what you said listener, we said Kafka 0 in this example, 9092. So what we do is we register with this IP. So now this application will connect to this directly now. So when I publish a message, I can connect to this now because I know the domain. So this is the difference between this listener and advertised listener. So if you want to maintain both the same, you can do that. Otherwise, you can say, I will allow the clients to connect to the only this, or I said I will allow the to connect from the 9094 that. So this is what the difference between the advertised host and the listener. I hope it makes sense for you. Okay. Now, let's say, so I will come back to the demo. So now, if you go and see in the log file somewhere here, you will see that you say creating broker ID 0. So I'll just try to help you. Yeah, he's saying broker ID with this. This is how the broker is. Please mute your mic if you're not talking to me. Now, we have the broker ID. This is called the G node, which the broker is trying to create in the Zookeeper with this information now. Okay, so in the log also, we have a lot of information here. So you see that at the first time, it's creating this node, and then it registers this address. Okay, so now let's try to see from the Zookeeper perspective. Now, at this point, I have connected to the Zookeeper now. Okay, so I've connected to Zookeeper now. So now let's try to see what all I have in the Zookeeper now. So when I run this command, I'm looking for all the data that this particular Zookeeper is handling for this cluster. So some of the things that you need to keep in mind when you try to understand when your Kafka cluster is not performing well, or when some issue is there. So what I can do is I can list down this is how I list down brokers, IDs, Okay, I will have 0 as a register 1. Now, I will have 1 also, and I will have 2 also. Why? Because we have 3 nodes, 0, 1, and 2. If I want to get some information about this, so what I'll do is a get. This is what I got it. So you see that my 0 is endpoint is at Kafka 09092, and my port is 9. So this is very important for you to understand it, because a lot of time you will be registering this is how your listener is registered here. If you have not configured the listener properly, then you will be registering it as a local host, and the client will not be able to accept that request, because he will be looking for the Kafka in the machine that is running to that. So you have this. Now, I can also, whenever you create a topic, that one entry goes here, okay? Brokers, and then topics. Here, nothing is there because we have not created it. So when we create it, we'll try to see that. One more important I want to mention here, there's one called the controller. Now, the Kafka is a cluster environment. That means you can have multiple machines combined together and give you a cluster environment. It's a peer-to-peer. So a lot of time people will say that, is it the Kafka is a master and slave architecture or peer-to-peer? But actually it's a peer-to-peer. However, at a one point in time, one of the Kafka cluster, one of the Kafka node become a controller. And the responsibility of this controller is to ensure that the distribution of the data in the cluster is well distributed, it's uniform. So the role of the controller is to ensure that the data are equally distributed among the Kafka cluster. So sometime your cluster deployment will not have the controller. So you have to come and look for here, so that, because if suppose this controller is the broker ID 0 and the system is not available, automatically the Kafka will do is will try to elect one more controller out of the existing 2 nodes. But if some problem is there and they're not able to elect this controller, then you'll have a problem. So you can debug that kind of issues out here by looking this, or you can remove the entry from here. Do not try to update this record directly unless you're very much sure about it. Okay. Now, let's create a topic for the understanding. So I'll just open my sheet so that I can just copy that. Now, I'll create a topic here called the My Kafka. So I copy here. So this is the syntax that we use to create a topic, the Kafka topic, create the server that I want to connect to create it, Kafka. Now you can give any one of the nodes, because when you connect to any one of the nodes, the metadata information is being derived from the Zookeeper and then pass on to the client. So you don't need to worry. So we are going to create the My Kafka. So we create this one Kafka. Okay. Now, once we create this Kafka, let's try to see what the changes that we have on the Zookeeper side. So earlier we don't have an entry. So now we have a topic called the My Kafka, and I have called the partition 0. So because by default it create 1 partitions. Okay. Now let's try to get some information about it. Get broker topic here. So these tell you some information about the topic. Now it says I have a partition 0, that means 1 log file, and I have stored that in the Kafka 0. Okay, because I have only 1 log file. Now I don't have any replicas and all, because we'll talk about the replicas and all. Now I will show you that this particular log is where. So now let's go back here. That actually this is stored in my temp, and if you remember it, we have specified this folder in your server.config. Now 3. This is where I store my data. So this is the log file that store your data. So you can also see about sizes. Okay. Oh, it has gone where? Yeah. It has partition 0, topic ID. Okay. 0 is where? No, sorry. We have not published anything message. Okay. So now the data will go in this particular log, but it's a 0 byte because we have not sent any record to now. Okay. Now let's try to understand. So this is how you look from the backend. Now let's see if you want to understand from the yeah, your admin, then you want to find out the list of the topic that this particular topic has it. Now what will happen is you run this command called list. So I have a topic called my Kafka, which we have created. Now I can also describe this topic. So I want to understand the technical behind it. Now my topic, the partition count is I have divided on only one, so I'll go in detail later on. This I'll go in detail later on. So my topic is my Kafka, partition 0. I'll talk about this later on. So I have the data all in the broker 0. Now let's see, I will send some record. This is how we sense the record, the CLI. So I'm saying I'm using the tools called Kafka Control Producer, and I am sending the record to my Kafka. I said, hello, how are you? I'm well. How is Kafka? So now I sense these records to the topics. Now, if I want to consume this message, what I'll is that is I will run this command here. So when I run this, I got all the messages that we have. So Kafka console consumer, the server that I want to connect for pushing the record, the topic that I want to connect, and I'm saying is give me the record from the beginning that what is there. So now, if you see in the log file, you see that the record size has been increased to log. Okay, so now the data that you inserted to the topic always goes to this log file. So this is how in the next demonstration, I will show you how to read this if you really want to see underlying. So when it talks about a topic, I'll try to show you what's how the data gets stored behind in that. So this is how the data gets stored. There are some topic called underscore consumer offset. This is where you keep track about the consuming part. This is automatically created by your consumer. And then you have an index about your logs, and the index can be also done in the time, depending on time. These are something that we do when we understand the Kafka internal well. Okay, so this is what the Kafka behind works. Now I'll move to the second topic. Okay, so I'll move on to the next topic here. Okay, I'm trying to touch upon some of the future that you can further explore. Okay, we go internal 1.5 days. That's an internal about understanding how the log work, because when you try to work on the transaction, okay, there is one called transaction coordinator, and we have a sequence number. when we generate the sequence number, then we bind the sequence number to the one transaction, and when one transaction fails, the data lies back on your record, and a lot of time it doesn't get removed because of some issues when we run the compaction. Then you as admin has to figure it out what really happened. If the programmer has not written the full-fledged transactional code, then you should be able to understand by debugging directly to that, because some people, there are some time you get complained that I have pushed around say 1,000 records yesterday at 1 o'clock, but I'm able to consume only 950 or something. Like, then you have to figure it out. Is it because you have enabled the isolation, but however, it doesn't suffice the requirement of your transaction? So that kind of things you need to understand when you work for that kind of stuff. Now, let's see some internal. It'll be too much for some of the people who are new, but it'll have you with an idea that the Kafka has a lot of things in this. Otherwise, I can just wind up the discussion with publisher and subscriber, and we just wind it up. But what I wanted that the people who have already worked here has to know more in that, because a lot of time they just configure a Kafka, insert a record and publish the record. They go to production, and when millions of record comes in, they don't know what's going behind, and they have a lot of issues in that. So I want that people to understand more that there are a lot of things you need to understand it when you work. That's from the performance and tuning part. And the people who are new have some idea and they work, and then they can start working on this with this idea what we talks about it. Otherwise, it will be without too much information. Now, let's try to address this information about the topic here. So I'll still again go back to the concepts. I have an order, and in the previous slide, in the demo, I have created with one partition. I can define a order topic with, say, in this case, 4 partitions. What I am saying is I will have a log file called the order, but in the backend, I'm going to divide into 4 parts. That means it's just like this. I have order log, it's a logical name, and in the backend, I'm going to have four files. So this is the beauty about your horizontal scaling out. This feature is not there in your IBM MQ series or any other, even in RabbitMQ or any other messaging systems. Okay. Now, what it does is I have divided the log into multiple parts. Each log is sometimes break up into a concept called log segment. Okay. I'll not go back to that because log segment is something that you need to tune. Okay. That's a physical. So when I said 0 and that 00.log, that's actually a log segment. Okay. You have to size your log segment properly. Now, the partition 1, each partition that you have some offset number. This is like offset 1 actually start from 0, but in this slide we just set 1, 2, 3, 4. That means this must record are there in my Kafka topics. Okay, in this particular partitions. Now this must is option here, this must here. So we have now, how do I do the scale out? Is that I can configure this partition 1 in node 1. I can configure into node 2. I can configure into node 3. I can configure into node 4. So now I can distribute this log into multiple nodes. So what the Kafka partition allow you to do that is you can partition your data into multiple nodes, and then you can move this partition across the node. So it is give you the capability to move the records to the multiple machine. So if I have to, then what happened? I can write your record in the multiple file at a time. Now, the record will keep on appending here. The next time when I write a record here, it will be 9. Next time, 10, 11. I don't keep on writing or I don't keep on looking. So this is called the append log. If I have to do the same thing in the other messaging topic, what they do is they create one log file. Now, since this physical file is only one, this bind to the one node. That means one machine. If this file becomes so huge, I can move this file to this, but I cannot do that half of the file here, half of the, it's not possible. But the Kafka with this partition of topic, you are allowed to store multiple. Now, the problem comes in here. The problem comes in here. When you have multiple partitions, in our example, we have only one partition, so we know that all the record has to go to this one file. Now, if I have 4 partitions or 3 partitions, I don't know where do I have to send. So should I send it here? Should I send it here? Should I send it here? So we have the challenges in that. So in order to determine the partition where the data will goes, the Kafka provide 3 options. One is called the round robin. That means first time he'll send it here, second time, third time, fourth time. So it will load balance your data across the node. Now, there is one called the custom partitioners or a priority that you can define that if the record is coming from, say, in India, send it to these partitions. If the record is coming from, say, Canada, send it to here. If it's coming from the Singapore, that it goes here. So depending upon the data, you can also ask the producer to push the record to these partitions. Another one is called the okay. Before I explain to the third one, whenever you send a record or a message, it's divided into 2 components. One is called a key, and another one is called value. The value is optional, actually. Okay, you can define a key. The key is optional. You can define a key. Say, for example, in order, you can say order ID is a key, and order value is a description about your order. So if the key is present, so in this example, we have the order coming by customer ID, this is the key. Then it can use the hash functions to determine the which partition to that. For example, if you have a topic with partition 3, what it does is he has a function called hash function. Inside it, he passed this 123. Actually, what it does is he does some hexadecimal conversion to 123, and 123, the mode of 3. So 123 mode of 3 is 0. So it will go to the partition 0. So suppose if I get a 124 number, even number, then actually 124 mode of 3 is 1. It will go to partition 1. If I send with author ID 125, the mode of 125 by 3, it will get around 2. Then it will go here. This way, the data get distributed. So the distribution of the data across a partition can be done by in a round robin ways or custom partitioners, or if you have a key. And by default, if you have a key, then it uses these algorithms to process the sender record. Now, this is from the when you configure the 2 things here. I divide my topic into partition 1, partition 2, and partition 3, 3 partitions, and I configure replication on top of that. So I configure 3 replications. That means copy. So how do you understand is, this is one broker, this is the second broker, and this is the third broker. Now, when a client producer use these the hash partition, say my key is 123, and I have 3 partitions. So my mode of 123 is 0. So the client will write your data on the partition 0 directly. Then it get, since I have configured replication factor of 3, then it will get copy in the other nodes. Okay. Now, when you have the same partitions get replicated among the brokers, the one that the Kafka write is called the leader. That's called leader partitions. And another are all called the follower partitions. Now, the one thing that you need to keep in mind is that all the read and write will always happen at the leader. So you cannot connect to this and write the fetch record from here. You have to always fetch from here. That's automatically taken care by the Kafka client, but the Kafka ensure that the data go from here. But if this leader dies because of some reason, either this or this will become the leader in the next cycle. So your data are intact all the time. Okay. Any doubt up till here? Any confusion that you have it? I'll just see the chat. Okay. Now, from the consumer perspective, what we do is that we have partition here. So in this partition 0, 1, 2, 3, 4, in the partition 0, I have 12 records. The producer, the order comes on like this. And your SMS application, one SMS application can pick it up from here. One SMS can pick it up from here. Okay. Now, what is the advantage is that your SMS application can run at this own speed and this one can own speed. It's not being compulsory that everyone has to consume at the same pace. Depending on your application client, you can do that. Now, if your SMS application has read this record and your application dies because of some reason, when you start this application again, the Kafka ensure that it starts from here. It will not start the consumption from here. If you want, you can say start from here again, but by default, it will always pick it up from here. Okay. Now, there's one concept called the consumer group. Say I have deployed one SMS application which consume the message from the order, and I send the informations to the client using SMS. Now I realize that just one instance can consume only 10 messages at a time. It's taking slow. So what I can do is that if I want to process 20 records at the same time, I can spawn one more application here. So then what will happen is Kafka will ensure that 10 will go here, 10 will go here. How we ensure that is you have to bind these two applications with one ID that's called the consumer group. So if I say the consumer group where its ID is 1, that means they belong to the same consumer group, but they divide it to that. However, they don't divide it the same partition into 2, but you need to have one more partition 1. This partition will be assigned to this, and this partition will be assigned to this. So this is how the assignment of these partitions to the consumer happens. Now, how this consumer assignment happen in the backend is that in this example, this is your consumer instance 0, consumer instance 1, and consumer instance 2. Like, for example, your SMS 1, SMS 2, SMS 3. Now, there is one broker which becomes a coordinator for that consumer group. So these all 3 nodes or consumer nodes will connect to them. Then the first consumer that connects to the coordinator becomes the group coordinator. Means he's the master of the consumer group. And then the coordinator inform back to all these consumer that this guy will become your consumer group coordinator. So he will be the responsible for allocating the consumers. Say, for example, I have 4 partitions. So it is the responsibility of this guy to allocate these to this, say for this 1, 2, 3, and 4. 1 will be allocated here, 2 will be allocated here, 3 here, and then the 4 here, because I don't have even number to that. Now, if one of them dies, then it is the responsibility of this guy to inform that, that this one will be assigned to him, because you can have evenly distributed. This is how the consumer group processing work with a group coordinator. Okay. We will have a demo. For how this works in the backend. Okay. Just give me 1 minute. I'll connect to that. So now I'm coming back to the demo now. So what we're going to do in a demo is that I'm going to create the topic now. Same, the different topic here. Yeah. So here, what I did is we supply 2 more parameters now, partition 4 and replication factor 2. So if I run this command, what I'm trying to say is I'm going to create a topic called my topics. It will be divided into 4 partitions, and then each of the partitions has to be replicated into 2 places. That means I'll have one master copy and one more slept copy in that. Okay. 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 Yeah, 2 hours is quite long. Okay. So now we create a topic. I'll talk. Let me just complete this demo, and then I'll show you what happened if this is a group coordinator fail. I'll talk about that. Okay. Now I create these 4 partitions and a replication factor of 2. So if I describe the topic now, if you see in this output here, you see that the partition count has been changed to 4 and replication is factor 2. Now, if you go to the earlier topic, my Kafka, that was 1 partitions and 1 replications. If you see that out here, the topic 0, topic 1, sorry, not the topic remained the same. The partition 0, 1, 2, and 3. Now the leader, if you remember in that is, the read and write will happen only on the leader. So the leader for this partition is there in the 1, the broker ID 1, and the replicas are in the 1 and 2. That means the copy of the partition 0 is going to have in 1 and 2. And there is one in sync replica. This tag means all my records are in sync. So in production, what will happen is sometime the connectivity between your the broker ID 1 and 2 is not that good because of network is TOGAF or some any configuration problem. Then there will be some delay into that. Then you will have to see what exactly the problem is there. But this is an ideal scenario where all the replicas are having the same copy. So ideally, you should have it. There are some configuration called the minimum in sync replica and all that I'll not talk about here because that has a lot of discussion we need to do in order to bring that data. But with this command, you can find out where is your partitions, who is the leader, and where is the replica. The ideal scenario in your production environment is the leader has to be distributed. So if you see that some leaders are in the 1, some leaders are in the 0, some in the 2. It should not happen that all the leaders are in the 1. If all the leaders are in the 1, means you have some problem. What does it mean is all the read write is going to happen in the 1 node, although you have 3 node cluster. So you have to look for that. Okay. Now, let's try to see now how the physical look like. See that? Now, in the earlier cases, I have only 1 folder because I have only 1 partition. Here is that I have a physical folder. Here 1, 2, 3. So I have 3 partitions to that. And each partition has its your log here. Now, data will get distributed among these 3. So let's try to see now here. I'll open one more terminal. Okay, so I'm running this the producer now. What I said is I'm going to have key now, and the separator for the key is the colon here. So I said streaming. So I said streaming colon Kafka. The streaming is a key, and the Kafka is the value. So I said NoSQL belongs to Couchbase. And I said NoSQL is MongoDB. Spark streaming is Spark. EI is Camel. Now I have produced 4 messages. 1, 2, 3, 4, 5. 5 messages now. Now let's consume this message. Okay, let's consume this message. So how I consume this message is that is, this is the parameters. I'm going to upload this command later on. See now, this is, I get consuming that. But let's see what's going behind in the file now. 3. I'll specify the size also. So here, most of the record goes in this. That means because it has gone by the key. So this has partitioner has moved out this here. So when you design the key, it has to be ensure that it generates the data in a such a way that it's equally distributed. If I do without a key, it becomes the round robin. Okay. Now let's try to see how it look like the data. Okay. It's in the wrong. That is my topic 3. See that if I open this file, so I have opened the partition 0 and I have opened this log file. So I can see that the starting offset is 0. Okay. And my key is streaming and my payload is Kafka. Now the second offset is base offset here, base offset 1, the second offset, then I am going to have the streaming, is Spark. Now this way, the Kafka store the data in the incremental way. Base offset 0, 1, 2 record, which is of the key of EI of the camel. So this data get distributed using the hashing, and then it gets stored in the actual log file. Now you can also get the partition wise the offset number. So what you can do is so if you run this command, so it said my topic, so I have 0 partitions, that 2 is the offset, the means 2 record, the topic 1 and 2 doesn't have any record, the partition 3 has the 3 record in that, so we can define like that. Okay. So any doubt up till, yeah, I'll come back to the query that you have it. So let me just stop my share and I share. So here. So someone was asking, when the group coordinator dies, how the group coordinator is selected? Is this true, Zookeeper? Yes, absolutely right. So what it does is there is one called the entry called the group coordinator for that consumer group. Say consumer group 1. These Z nodes, okay, that will become blank. That means because my heartbeat has to go. So for example, the coordinator 1 for this is the coordinator is the broker 1. So he registered himself. But suppose if this node dies away because he's not able to send the heartbeat to this guy, so then it get informed. But now then again, when you have this heartbeat has to go to the broker also, the broker of the brokers. So that because the heartbeat has to go there and then it has to sit in the Zookeeper. And then I want to highlight here again, depending upon which version, the Zookeeper is going to remove now, and the next version is called the KRAF. So they will no longer maintain the data in Zookeeper. If you're using 3.6, you can configure in two modes, that is in the KRAF mode and in Zookeeper mode. However, the KRAF is not recommended for production for time being, but down the line, there will be new Zookeeper per se in the deployment. Now, coming back to the last topic, which is I'll take slightly around 5 minutes to demonstrate to have an idea what all you have other than this. Because when you walk out from this presentation, you have an idea that what are the features that you need to use it when you deploy in that. So we call it Kafka ecosystems. Now, this is the big ecosystem now. When I'm just touching these some of the parts so that you have an idea how it works. But Kafka has gone as enterprise system now. So, like for example, this is your Kafka cluster, which you have a broker in Zookeeper, which we have demonstrated, and this is your producer that I have demonstrated how to push the record. And this is your consumer that consume the message from there. Now, if you have a database, say an Oracle or an MySQL, you want to bring the data inside to the Kafka, we have one tool called Kafka Connector. So there are different libraries that allow you to bring the data from different sources to that. You can even bring from the file. You can even connect from the MongoDB, Couchbase, and all. You can bring the here. And if you want to send this data from the Kafka to another database or other system, we use the Kafka Connect Sync. Source means to bring the data in, sync means to out. Now, if you want to fetch the data from the Kafka cluster and do some transformation, we have Kafka Stream app. And if you want to define the schema of the Kafka, then you have schema registry. For example, if I said order is my topic and ID should be of, say, integer, order values should be of double, order description should be of some string. So if you want to define this kind of schema for your message, then you have schema registry, okay? Now, if you want to deploy one cluster here, say, for example, in Singapore, and if you want to deploy some more cluster in, say, Bangalore, then how do you do that is you can synchronize your data using this mirror maker, okay? So why we need to do is that is one for disaster, because you can have copy, or you can even use for your data analytics. So you don't want to touch upon this, you can do it. So these are all the components that you have it when you want to deploy the Kafka. Now, if you want to access your Kafka using REST API, we have a REST proxy. Now, there is one more called the ksqlDB now. So I'll just show you some of that feature here. If you want to say you push the record from your order databases and put it in your order topic. So if you want to do some transformation, this Stream API will help you to that. In this example, what you're doing is that is first you need to define the Stream Builder class that will allow you to configure your transformation. So this is more on transformation, okay? Now, when I have this object here, so I said .stream, that means I am actually connecting this to the topic users. So what I am doing is that is I am going to receive the record continuously, and I'm going to have the record in the form of KStream. This is a key and this is a value. If you have the key, say for example, order ID is 12, and I have a JSON value of order details, this would be your key and this is a value. Once you have this key, you can have the loop, you can loop the record for it. That means I want to loop all the record in the collection, it returns as a collection. And this is your Lambda expressions where you have to input parameter in key and the value format. Then you can print out or you can do any manipulations. If you want to do transformation, you can say map, /map. I'm not going to detail, filter, you have all, like, you can have aggregation, you can have group by, all the things that you want to transform can be done on the real time using the Stream API. And these properties will help you to define your which broker ID you want to connect, what's the port number, what's the user ID to connect if you configure security. That properties you'll define here. And this, what you define as a transformation, is called topology in terms of Kafka stream. Then you bind that both configuration and you have a Kafka stream and you just start it. This way you can continuously receive your record whenever any changes happen in the order topic. This API is called Kafka stream. So if you are a developer who is going to write a lot of code from fetching from the Kafka, this is what you have to learn. Okay. The last of the day is another way of fetching the record is called the ksqlDB. ksqlDB is come in two flavors. One is called the ksql and one is called the ksqlDB. The ksqlDB is a combination of ksql plus the connector. So in some of your books, you'll say ksql, that's earlier version, and new version is ksqlDB because they have combined it connected to that. So ksqlDB is your another deployment where it's a combination of a KStream connector, and you can also create a views. The main difference with the ksql is you don't need to learn all this concept now. Sorry, you don't need to learn this syntax, which is a little bit complicated. But with ksqlDB, you can write, say, create a stream like your SQL, create a stream called movements. So this is your movement. And I'm going to have one more field called person, which is of type varchar. And this is my key. And I will have one more field called location of type varchar with value. So I can define the JSON value to store my data. I will have one partitions. And the topic that is I'm going to have on the behind is called movement. So it's nothing. You'll have your broker. Your topic will be here. And he create a wrapper on that. Now, once you define like this, you can treat this as your table. You insert the record with insert into movement, the value like your databases. You can insert multiple record, and you can fetch the record like select star from table. And then you can do group by, where you can do order by. All that, most of the features of the T-SQL can be applied. So this is the best way of deploying your Kafka if you're deploying your Kafka recently. Okay. Now, thank you. That's from my side. If you have any query, I will try to address here. Okay. Okay. So I think Indrajit is having still a doubt. So anyone has any issue, please type it here. I'll try to address here itself. So I'll just address here.
Yeah, we have few questions on chat.
Sure, I'll just address that. And then just put it here. Now, first thing is Indrajit is having still a doubt about the public, private, and advertised source. Actually, we don't have public, private, or advertised source. We have listener, or we call it advertised listener. So we have two concepts which Kafka allow you to configure called listener and advertised listener. Listener is, as I told you before, when Kafka, say, for example, this is a Kafka node. So in any machine, when we deploy in any applications, and it can have multiple NIC cards. So say one NIC card is 10.72.1.10. So this is a private IP. So that is how we call as a public private. I'm not sure how we address, but in Kafka, there's no any concept called public private or advertised host. But the concept is like this. So, but if you're trying to say the exposing your private IP or public IP is about your netting, that's you have in the network concept. But here it's another NIC card. I address 2.22. So I have two NIC card. and I address, and one more call the loopback address. If you remember, if you have an idea, 127.0.01. This is one. So you have 3 IP address configure, and then you have one more called the localhost from the domain name, and another one is called your DNS configure if you have configured your hostname resolution to that. So when the Kafka first start up its service, it has to bind to some port and some configuration IP to address. So he doesn't know which one to bind because you have a lot of configuration. So by default, he binds to localhost. Now, if I bind the default, say, let's see what are the implications to that. I start up my Kafka with this listener called the localhost. So if I don't specify this, these get override by this. Okay. Now, if I don't define this for time being, what I'll do is when I have my Zookeeper. If you remember in the Zookeeper, we have one called the brokers, IDs, and 0, because this is a broker host 0. I assume that he will register as the O as a localhost. But if a client connect to this, he say localhost means he will look for that broker inside the client, because the client will run from the another machines, then it will fail. So what you have to ideally do that is, I can say that when do you want to override this feature, then I will say advertise listener. Then I can overriding this localhost, and I say, this is my Kafka 0. If you remember, this is my host name, 9092. Even IP you should not bind, you always should bind the host name. So I replace this localhost with the Kafka 09092. So what I'm allowing is I'm saying is with the advertised listener, I am going to allow the client to connect to my server using this domain name and this port number. So when I override this, the client get a metadata of this information, and he will be able to connect to this machine directly. So that's the difference between the advertised listener and the listener. So by default, if you don't want to maintain differently, keep the listener and advertised listener same. Otherwise, what we can do is that listener, you put 0.0.0. That means it will listen to all the IP configuration, but I don't want the client to connect to any one of this except this one. That you can do. Okay. Now, the second point is from the Mr. Mid is that is KSQL ANSI SQL compliant? Yes, but partially, because it has you don't have the views and all. It has created views to support the pool, but it doesn't support all the compliance of that. But 60 to 70% of the ASNI SQL recommendations are compliance with that. Okay, that's it from my side.
I got one last question. Hello.
Sure. Yeah, sure.
My question is this, generally Kafka say that in a second it can process 1 million of message. But
Okay.
when I was reading that documentation, they say that if we increase the number of nodes, it can process 1 million of message, like 2 billion of message. Then is there any formula which I can, if I increase the number of nodes, I can increase the message size in a second?
Okay. Indrajit, I am before I address, I'm just trying to interpret your query. Just correct me if I'm wrong. What I understood from your saying is, I can process 1 million records, and if I increase the number of nodes, I can increase to 1 billion. This is what you were trying to ask?
Yeah, that's what I read in the notebook, in the Confluent page, not 1 billion, 2 billion they are given. From 3-node cluster to 5-node cluster, if we increase, then we can increase the message size to 2 million. Then I am just looking forward. I do not find any document which give the reference document. If we increase 10 node, then how much message intake I can increase? That detail I do not find anywhere.
Okay. To address this your query, it's not like that. It's not like, because if they are saying is not correct. Okay, see, you can see my screen whiteboard, right?
Yes.
See, but how it works is like this. Say, for example, I have one node. And if I have only one partition, for example, I'm just discussing that. So when I said I have partition one load, means I am going to have one log. If my disk IO means I may say, there's one tool called the performance tool provided from the Kafka tools. Okay, if you want this more in detail, you just give me one mail. I can send you one few commands that you can do. That means in a particular node that you have it, how much throughput you're going to get it. That means if I push around millions of messages in 1 second, how much I'm going to read it with various parameters, because I have parameter called buffer configuration, then I have TCP/IP configuration, socket buffer. I have a lot of configuration. And there is one more configuration which is very important called the ACK. Okay, the ACK, as a developer, you can configure as a 0, 1, and all. That will change all the scenario that you have. It 0 means you get acknowledgement from the buffer. 1 means you get acknowledgement from your leader. And all means you get acknowledgement from all the replica. The more you increase from 0, 1, and all, you're going to have a lot of latency. But coming back to your, in a very simply ways of expressing it, if I have only one partitions, and if I am able to process about, say, 1 million messages per second for time being, if I add one more nodes, as you are saying, it will not impact anything. Why? Because your partition 1 is here. There is no way a single partition can be also here. Replica can be here, but you cannot do that. What you have to do if you want to use this node 2 to get part of your processing is you have to divide your partition from 1 to partition 1 and partition 2. So you'll have partition 2 here. So if you are increasing your node without increasing your partition number, your performance is not going to change at all. So the more the nodes, the more the partition that you have to do that. There are some scientific ways with calculations of the partitions. Like, for example, if I have 10,000 messages per second, and I want to process in 1 millisecond, how many partition and how many nodes I need to have it, that's a mathematical calculation. If you want to know about this formula, I can send you one right after you. Just put a mail to me. I'll send you that, which we use it for sizing. So that's called a sizing. But you cannot just say, I add one more node and my performance is going to improve by double. No. You have to increase the number of partitions. You have to increase the number of threads. You have to increase the number of consumer groups. You have to increase the number of consumer inside the consumer group. And there's one called the number of tags. These are the parameters that you have to attribute. And even you need to specify your ACK. Where do you want to have a specified ACK? And there is one called the main in sync replica. If you don't define all this parameter properly in sync, then you are not going to get the performance like double the scale. You have to configure something on behind. Okay.
Great. Thank you, Henry. Any further question, guys? Anyone has any doubt, want to ask? Okay, fine. Henry, would like to say really thanks to you for your time in this insightful session.
Yes.
It's really well. All the topics, I'm sure all the attendees must have get some benefit by this. And in case you guys have any doubt or any further question, Henry shared his email ID. You can, Henry, post on chat as well for people reference. You can reach out to him directly, and I have shared my email ID for your feedback and suggestion, what topics we can include in like next upcoming meetup. That will help.
Okay, thank you thank you everyone. I hope you enjoy my sessions. You can connect to me live.scholar. In case you have any doubt related to this, I can send you the relevant information for that.